Hello, everybody. Welcome back. Today, I'm going to be talking about inverse functions. So, basically, the inverse function can be denoted. It can be denoted by f with a little minus one's superscript there, x, right? So this is going to be our inverse of f of x. So what is the inverse? Basically, the inverse is when all the x values are the y values and the y values are the x values. So when it comes to a table of values, all we have to do is switch the x values with the y values. So for example, if this is f of x in our first example, then our inverse function, the inverse of f of x denoted this way, would be, instead of 1, 5, it would be 5, 1. Instead of 2, 8, it's 8, 2. And instead of 3, 11, it's 11, 3. So all I did is I swapped the x values and the y values because that's what an inverse function is. It's where we swap our x's and our y's. Now, what about for this graph? Same thing. We need to swap our x's and our y's. And if we swap our x and our y values, what will we get? Well, let's see. This point is 0, 3. So therefore, the corresponding point would be 3, 0 over here. What about this point? This point is 1, 6. So that means 6, 1 would be corresponding point here. This point here is negative 1, 0. So that means that 0, negative 1, which is here, would be the corresponding point. And you might notice something at this point is that all of this is the reflection through the y equals x axis, right? So that's what this is. That's what this is essentially. There we go, right? There it is. So this is the same thing, right? But reflected in the y equals x axis. So if we take any function, we reflect it in this axis, we will get the inverse function. So I'm going to label this. This is our original function, we're still in math mode, f of x. And this is our inverse function. There we go. Okay, now what if it's from an equation? What we do is we're going to switch the x and y values, and then we're going to solve for our new y. So there's actually 4 steps I want to talk about when it comes to these, okay? So step 1 for finding the inverse from an equation, and actually let's label this as finding an inverse from an equation, okay? So step 1 is to switch, is to, or I should say sub f of x, or whatever our function is, to y. We're going to switch from f of x to y. Step 2 is we're going to, now for inverse, we're going to swap x and y. Step 3 is we're going to solve for new y. And then step 4 is we're going to sub equals y, or I should say y equals to our inverse notation if the inverse is a function. And that's a key point here, that sometimes the inverse of a function is not itself a function. And so in those cases, we would not do step 4. if the inverse is not a function, because this is part of function notation, and so it must pass the vertical line test. So when it comes to lines, there are some general rules we can kind of know here. When it comes to lines, whenever we take the inverse of a line, as long as the inverse isn't the vertical line itself, then it should pass the vertical line test. Okay, and so for almost every single line, it should work that the inverse is indeed going to be a function. Now, what about a quadratic where we have y equals ax squared plus bx plus c? In those cases, it's almost, it's never going to work, because if we have some quadratic here and then we're making it a sideways quadratic, well, now it fails the vertical line test, right? And so whenever we find the inverse of a quadratic, it's not going to end up being a function itself, right? And so there are some general rules like that, or same with the absolute value, right? If we turn the absolute value on its side, right, is that going to end up being a function? Still, no, it isn't. And so that's just something to kind of keep in mind. So this one is linear, right? It's the y equals mx plus b form, and so this one should be good. I'm still going to go through all the steps and show how it is, but this one should end up as a function as our inverse. So let's do that. My first step is going to be in step 1, which is y equals 3x plus 7. So here I just replaced f of x with y. And then step 2 is actually where we're going to start to find the inverse. So for inverse, we're going to have x equals 3y plus 7. And then we've got to solve for our new y. So I'm going to subtract 7 from both sides to get 3y equals x minus 7. Then I'm going to divide both sides by 3, so I will get y equals x over 3 minus 7 over 3. And this is indeed a function, right? This is another y equals mx plus b scenario, and it's not a vertical line itself. So therefore, we can use our new function notation. I keep writing prime for some reason, but no, this is the correct notation, not prime. X over 3 minus 7 over 3. And that's the final answer. If they ask what's the inverse, that is the inverse right there. Okay, let's try a couple more examples. Find the inverse of this quadratic function and set the domain for f of x so the inverse is a function. Okay, because here they're recognizing that, hey, this is a quadratic, the inverse is not going to be a function, but if we set the domain a specific way, maybe it could be a function, is what they're saying. Okay, so let's go ahead and do that. So the first thing I'm going to do is I'm going to graph the original. I think I'm going to graph the original in orange. So I will just box this in orange to show that this is my original function, or I'll underline it. I think that's good enough. So how do we graph a quadratic again? Let's do a quick review on this. That said, if you're unfamiliar with how to graph a quadratic in vertex form, do make sure to go back and review that, as I think that was material back from grade 10, and also was retaught in grade 11 as well. So either one of those would be good. But fast review here, though. We know the vertex is -2, 1, so the vertex would be here. And we also know that we're doing a vertical stretch by 0.5, which is really going to be a compression, right? So instead of over 1, up 1, it's over 1, up a half. Instead of over 2, up 4, it's just going to be over 2, up 2, like this. Like that. Okay. So now it's asking us to set the domain of f of x so the inverse is a function. So let's first find the inverse itself, and then we're going to set the domain at the very end of f of x originally so that we end up with a function. Because naturally, we're not going to end up with a function by taking the inverse of this. Okay, so what's my first step is just we're going to replace f of x with y. And then for inverse, I'm going to swap x and y. So x equals 0.5, y plus 2 squared plus 1. Then we're going to subtract 1 and divide by 0.5, which actually 0.5, that's the same as a half. So I might switch that. That might make our lives a little easier. Okay, so then we're going to have y plus 2 squared on one side, and on the other side we'll have x minus 1 times 2. Okay, and that's just going to be equal to 2x minus 2. All right, then we're going to square root that. So square root of 2x minus 2, and then minus 2 at the end as well. Yes, minus 2 at the end as well for y. There we go. Okay, so now we found our inverse function. Now, what do we have to set the domain to in order to be able to make the inverse a function? Well, for the inverse to be a function, we can't have any of this, we can't have any of this symmetry, right? So if we just choose one of these sides, we'll be okay, right? So if we set the domain that the domain can only be from -2 and above, right, with respect to x, then the inverse will be a function. Okay, so if we set the domain of f of x to -2, x must be greater than or equal to -2, then the inverse is a function. Or another way you could write it, you could also write it in the other notation. So this notation here, -2 to infinity, and it should be including -2, then that's another way to write this as well. So either one of those, whether it's set notation or interval notation, is completely fine for this purpose. Now, if your teacher specifically wants you to write in one of the notations, definitely do. But otherwise, unless it specifies which notation to write in, both of these are good, valid notations to use. Okay, awesome. So now let's do it. Let's draw this function here. So this function here, again, we need to just swap the points, right? So we need to swap the points to find the other function, or we can graph this function specifically as well, would work too. But I would prefer to just swap. So let's do that. So -2, 1. So that means 2, -1. So over here. Okay, what about this one? This is -1, 1.5. So 1.5. -1. So that's going to be right there, right? Because we have -1.5, right? So here we're going to have a half. Oh, did I draw the first one incorrectly? Yeah, because here we have 2, -2, 1. I did draw the first one incorrectly. That's why I was confused. Okay. Yes, this one should be here. My apologies. Okay. So the next one is -1.5, right? So it should be a half, 1.5, and then -1. So that should be here. Okay, what about the third point? It's at 0, 3. So this one should be at 3, 0, like that. And our graph is going to look like that. So as you can see, we're drawing only half of the sideways parabola. We're not really drawing the full sideways parabola because we want it to be a function. And so there we go. Now it is. So with that constraint, we actually can write this in the function notation. When we have this constraint, right? So now what is the constraint that we need to put on this one? Right? When for f of x, we have this constricted domain. Or we could write it this way as well. Awesome. There we go. Okay, let's try number 3. Number 3 says find the inverse of the following function and graph both functions. Okay, so let's first do the first part of that, which is find the inverse. So to find the inverse, we're going to have y equals 1 over x minus 2. So for inverse, we're going to have x equals 1 over y minus 2. So then let's swap those two. We want to solve for new y. So that means y minus 2 would equal 1 over x, which means y would equal 1 over x plus 2. Okay, very good. And is that a function? Is there any way we could plug in some value for x and get two separate values for y? And no, if we do 1 over some x value and then we add 2 to it, there's no way that we can do that and end up with two different values, right? There's no square root sign that could make us end up with two different values, or any other thing that could make us end up with two different values here. And so the answer is no, and therefore the inverse is a function as well. Okay, so now let's graph it says graph both functions here. So to graph both functions, we could do a couple things. We could either use table of values, right? We could just sub in a few values and kind of figure it out that way. Or we could also use our transformations. And I think the way they're expecting us to do this here is to use our transformations. So we have to ask ourselves, how are these things transformed from the original 1 over x function, from the original parent function? And this first one up here, the original one, our original graph, the only transformation here is that we're going to shift right to, right? And so our new x-axis, or our asymptote, is going to shift right to as well. Now, what about for this one here? It is shift up to, right? For our inverse, looks like for the inverse, they want us to shift up to, right? So we're going to shift up to like this, and there we go. Okay, now let's draw both of them. So we know that for 1 over x, that we have 1, 1, like that, and then we have 1 like there, and then we kind of just draw like that. And then we have the same thing on this side here. Okay. And then we have this function like that. Yeah, there we go. And does this look right to us, right? Like, does this look as though we have, do these look like inverses of one another, right? If we were to draw a line through y equals x and then swap, would we get it? And yeah, we absolutely would. All right, so that is everything for today. Good work today, everyone, and I will see everybody next day. Bye, everyone.